That's
Gonna be rough.
he's gonna watch.
He's gonna watch it? Yeah. Yes. All right. So limits with now infinity. So I'm gonna write some properties down here about these limits with infinity. The limit as x approaches negative infinity of x to the n when n is even.
Yeah, we're doing properties now.
Yeah, we're on properties with the infinity stuff. N is odd. And I'll stop right there before I freak you out with the next one. Okay. Okay, I want you to think mathematically with me again. Come back to this idea of infinity. Infinity is a what did we just say? A very large number. That's what this guy is. A very large number. If you were to plug in a very large number and then square it, what are you going to get out?
An even larger number.
An even larger number. What if you were to take that number and cube it? What are you going to get out?
Even larger.
Even larger number. So what would be the limit of, as x approaches infinity, of some power function here?
Just X. A large number.
A large number. How do we write that?
Infinity. Double infinity.
Okay, now let's do it as x is getting to be a very large negative number. A large negative number, but my exponent is even.
So it's going to be infinity because it's positive.
Why?
Because it's like positive.
Because what happens if you took negative 100 and squared it? What about negative 1,000? It goes positive, right? So my answer would be infinity. Yes or no? Are you with me?
I agree.
Okay. What if this large negative number, and this was odd?
Negative.
Why?
Because you have a negative that it stays.
It's negative times a negative times a negative. Isn't that still negative? It'd just be negatively larger.
Yeah.
Okay. Thank you. All right. All right. Now that you've gotten that, do not freak out by this little property here that you're about to see. Write it down, and then I will explain it with an example. Let P of x equal a sub n x to the n plus dot 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 plus a sub 1x plus a sub 0 a polynomial. Then the limit as x approaches plus or minus infinity of the polynomial is equal to the limit as x approaches infinity of a sub n x to the n, or the limit as x approaches negative infinity, a sub n x to the n. Anybody know what I just said?
No.
Just write it down. It's fine. I'm going to give you an example in a minute, and you will have one of these on homework tonight. Don't freak out. It's not that hard.
Or if they were easy. Overthinking. No, undertaker.
All right.
Wait, is that like the backup to the problem?
This is an actual problem that you'll see on homework tonight. This is the property where it applies to. Okay?
It's a property?
This is the property.
That's the
How
problem.
is the property same?
They're the same.
Wow.
Okay? So I'm giving you this long polynomial. Do you all agree?
Yeah.
Negative 5x cubed minus 2x squared plus 5x plus 7. And I'm telling you, tell me what the limit is as x approaches a very large number. Are you all agree that's what that means? A very large negative number. Thank you for correcting me. A very large negative. This property says the following, that you really only have to look at what?
So A of n of,
Meaning what?
you look at the first and
You really only have to look at the degree of the first term of the polynomial. That the rest of this really kind of means nothing. Here's why. If you plug a large negative number in for x right now, again, just think in your head like negative 1,000. What's negative 1,000 cubed?
Negative.
Still negative, right? But then multiply it by the negative 5 on the outside. Now what would it do? Oh, now it'd be really largely positively, correct? That's not even right, but whatever. So do you see what I'm going? I'm picking a large number like negative 1,000. I'm cubing it. Wouldn't that still stay negative? But then when I multiply it by the negative 5, it would now become what? Positive. It would be large though, right?
Yeah.
Does the rest of this matter? No. The answer is infinity. That's what all that meant.
So it would be like squared times negative 5 would be negative infinity, right?
Right.
What if all the stuff after it is like ends up being bigger than
But it won't. Not with the degree.
Yeah.
All right. Now the last and final property, and then we are going to do 3 examples on it, and then we're done. I mean, officially done. Here's the property. Cake. Okay, write this down. Again, this is all, and the only time you can use these properties is when it says it's going to infinity, when it's going to infinity. Oh, you never use these properties any other time, only when it's going to infinity, okay? If it's going to 4, you plug it in, plug it in. All right, so here's what this one says. The limit as x goes to positive or negative infinity, if you're left with an x in the bottom of a fraction, look, your limit is 0. Let me say that again. If you're going to infinity and you're left with an x in the bottom, x in bottom of the fraction, then your limit is 0. Why is that the case? Well, think about it. If I had 1 divided by 1,000,000, isn't that really, really tiny? Like, isn't that close to 0? Okay. What's 1 divided by 1,000,000,000? Still really, really close to 0. All right. We're going to use this right now and do our last final examples. Can you handle this? You're doing so well, so I'm so proud of you. I might bring you something tomorrow of specialness, maybe. We'll see. Because I know it's rough.
Are we doing better than the other class?
The other class, we had more dance parties in here. They didn't have a lot of dance parties, so. No naps. Come on, we got this. We have got this.
No, tomorrow.
Negative.
Why not?
Negative infinity.
I'm finished.
How about next Tuesday?
Negative. We got to get going.
What about the day before the
The day before the final.
I think the example
The day of the final. He's coming here.
Keep this rolling, keep this rolling.
All right, write these all down. I'm going to show you a trick that many people don't know how to do.
So if we don't have to take the final, can we come here and not talk about it?
Sure.
If we have, if it is college credit in spring, do we have to take college credit?
Yes. But you don't have to come that last day.
Should we space these out like you did?
Yeah. Okay. Again. Come on. We're done after this. We're done. I know it's rough. I know you've had a long one. Okay. So there is a property in mathematics that says that you are allowed to, you're just always been allowed, whatever you do to the top, you've done to the bottom, right? Have you heard of that before? Okay. I am going to use this property of take whatever the highest degree is of x and divide everything by it.
Can you move the thing?
Yeah, I'm sorry. Okay. There we go. Take the highest degree of x and divide everything. Now, again, you only do this when you're going to infinity. Only. Don't do it any other. If this says 4, you plug it in, plug it in. If it says infinity, you're allowed to do what I'm about to do. And you only do it with fractions, by the way. You don't do it with a polynomial. You use the other property with the polynomial. All right, what's the highest degree of x in this problem right here? It is It is x, just the value of the degree x. Okay, so you are going to divide everything by an x. Whatever you do on the top, you can do it on the bottom. It's allowed in math. Why? Because it's allowed. Okay, now, if you can reduce it, reduce it. If not, it goes to something else. So here's what I mean. Does this reduce?
Yes.
What does it reduce to? So the limit as x approaches infinity, no matter what, is this one is going to be 4. Okay? Does this one reduce? What does that reduce to?
8.
The limit of that one is going to be 8. But if it has an x in the bottom,
Just an X?
look, just an x, and your x is going to infinity. If it has an x in the bottom, the limit according to this property is 0, right? Isn't that what you just wrote? So this guy goes to 0. Guess what this guy goes to?
0.
So what is your final answer?
1/2.
4 over 8 or 1/2. That's the limit.
Why did you call it the numerator 5 over x?
Why did I get rid of the numerator 5 over x?
Like, I know.
You have to put, whatever you do to the top, you have to do to everything on the top. You have to do divide by x, divide by x, divide by x, divide by x. All right, so let's do that again to this one, because this is going to negative infinity. What's the highest degree?
3 x cubed.
X cubed. So I'm going to do 6x squared over x cubed minus x over x cubed divided by 3x cubed over x cubed plus 1 over x cubed. If it can reduce, reduce it. Is there anything up here that can reduce?
Yes. 3x. It's just 6x cubed.
This goes to 3. This would, though, be 6 over x. If it has an x in the bottom, it goes to 0.
So 2 zeros on the top? What?
That's okay. Am I allowed to have 0 on top?
Yes.
I am.
I don't never remember which one.
What is this one? Does this go to 0 or does this go to an actual number?
That's a 0.
It goes to 0. It has an x in the bottom. So I have 0 minus 0, which is 0, over 3 plus 0, which is 3. Is that okay in mathematics?
Yes.
That is, what's that answer?
0.
That's the answer.
That's insane. Wow.
All right, let's do one more.
Wait.
Okay. You take the highest degree
Yeah.
and divide it by every single thing you see as long as the limit is going to infinity.
Okay, so if you
Zero.
divide by.
So you're going to divide by what?
X to the 4.
X to the 4th. Divide this one by x to the 4th. Divide this one by x to the 4th. If it can reduce, reduce it. Does this reduce?
Yes.
To what?
5.
Does this one reduce?
No. There's 0.
It goes to what? Is there an x in the bottom? It goes to 0. Is there an x in the bottom?
Yes, 0.
Oh, whoa. What do I have now?
5 over 0.
Okay. Do not be tempted to say DNE
You should.
because you ended up with a 0. You must use your calculator to double check before you say DNE. So right now, use your calculator, plug in a very large number, and tell me what the answer is. And then we're done
For the X.
for this one right here. Plug in a very large number for x. Put it in your calculator.